So let's discuss the next version of student 2.c, which does linear chaining, which implements a linked list in each hash bucket, and which does like that. So it is broadly the same program, student 1.c, but enhanced slightly. So what is the enhancement we will see? First thing is we have to chain these records together. So a next pointer is added in the struct student. Remaining things are as early, but we have added this next link, and now this hash table is a array of pointers, array of student t star pointers. So basically, if we want to visualize, our hash table is basically a array of pointers. Okay, every bucket has a pointer, and every pointer is a head pointer. So at every bucket we have a linked list. Okay, we have a linked list, and it's terminated. So basically you can relate this hash table is this array. Okay, this array, and this pointer is to student t, and student t is like the node of a linked list. It has a next pointer, and you chain them together. So this is like linear chaining approach. So that's fine. Hash table is the still old one, not very great, but it doesn't use all the characters. Hash function is still the old one. It can be improved, as we discussed earlier. This code is unchanged. When you have to insert an element, then naturally now you will allocate a node, you will malloc, and so that is just like inserting to a linked list kind of code, which is very similar. So here we insert it into the linked list. Okay, and we do insert at beginning. We don't do insert at end, because insert at beginning is efficient. If you have to insert a new node, you can simply say malloc, set this pointer here, set this pointer here. So that's order 1. I mean, although in linked list, in hash table, these linked list will be small, so even if you traverse, you don't lose much, because the linked list is supposed to be small. But still, why traverse? If I can insert in the order doesn't matter. So insert at begin is what we are doing. Right now the code is not doing duplication check. Maybe it can be added it. Just I have given a comment. So we simply insert is like we go to the index, we allocate a node, insert at the beginning. That's all. That's insert. Searching is simple. You go to the index, and then you will search for the node in the linked list. So this is very similar to searching for a node in a linked list. You situate a pointer at head, this pointer is situated at head, and you keep moving to the next node till you get what you are looking for, or it becomes null. Okay, and so if you get what you are looking for, you copy the data just the same way as the student 1.c into the output parameters. So search is basically same code as searching for a given value in a linked list, and you get to the linked list by getting to the index, which is returned by the hash function. So quite simple. And delete is, as you can guess, delete is deleting a node in a linked list. So basically the logic is simple. You start at the pointer, you locate the node, and you free it. Okay, print hash table, kind of just the same. So basically, more or less, if you take a file diff, not many lines have changed between student 1 and student 2. The only thing is, now we are operating on the linked list. We are inserting in beginning of a linked list, searching in a linked list, deleting in the linked list. That is the only change. Remaining things remain as it is, and you can run it and it will behave in the same manner.